Hello, Mr. Betts here. I want to take a look at an example that uses these new rules that we've been talking about for taking derivatives of functions and using shortcuts and apply it to something we haven't talked about yet that is power series. So a power series is essentially an infinitely long polynomial. So this sum right here defines a power series. And so before we even look at what the question's asking for, I want to write out this sum right here in a notation that's a little bit more familiar to us. So hopefully you understand what the sigma notation here means. And so let's write out some terms for f of x. So what the sum means is we're going to take 0 and we're going to plug it in for k. And we get x to the 0 power, and that's just going to be 1. And then we increment 0. So now instead of 0, we're going to plug 1 in. So we plug 1 in for k, and that's going to be x to the first power. And since it's a sigma, we're going to be adding these terms together. Since the upper limit is infinity, this is going to go on forever. Obviously, we can't write out infinitely many terms, but I'm going to write out enough that I know we'll be able to answer the question with. So let's go with k equals 2 is going to give us x squared. K equals 3 is going to give us x cubed. K equals 4 is going to give us x to the fourth power, and so on. Now, the question's asking for something that includes what's called a general term. And a general term basically means if we plug in any number that we want, or if we want to figure out what's the 100th term or the 1500th term or the 1 millionth term, we can just plug in those numbers to figure out what that term is going to be. So the general term here is just going to be x to the k. And what that tells us is if we want the 100th term, then we plug 100 in for k. That's actually the 101st term because the first term is when k equals 0, but you get the idea. So we can figure out what any term in the series is going to be by using this general term here. So what the question's asking for now is essentially the derivative of this power series. And we know using these rules that we've talked about, so the constant rule, the sum and difference rule, the constant multiple rule, along with the power rule, we know how to take the derivative of any polynomial. So we can take the derivative of this polynomial. So let's do that term by term. So the sum rule says that we can just look at each term individually. The derivative of 1, which is a constant, is going to be 0. Since we're going to have more terms in this, I'm not even going to write that 0 down. The derivative of x, so that's x to the first power, so that's going to be 1x to the 0 power, which is just 1. Then we have the derivative of x squared, which is 2x to the first power. The derivative of x cubed is 3x squared. The derivative of x to the fourth is going to be 4x cubed, and so on. So if we had more terms written out in f of x, we could take the derivative of more terms. You can see a pattern here, and you could use this pattern to write a general term for this. So you can see that the coefficients are increasing by 1 and the exponents are increasing by 1, but they're 1 less than the coefficient. Using that pattern, you could write the general term. What I'm going to do though is I'm actually going to take the derivative of the general term up here to get the general term in the derivative. So taking the derivative of x to the k is just a matter of applying the power rule almost directly. So we're going to get k times x to the k minus 1. And so what that tells us is if we want the 100th term in this derivative, then this is going to be 100x to the 99th power. We could plug any number we want in for k, and that's going to give us one of the terms in this infinitely long polynomial. And that's it. So kind of a weird idea that we would have a polynomial that goes on forever. It does have some applications that we're going to get much deeper into later in the class. This is a BC topic, so it's BC students only will be doing that. But it's a pretty basic idea. We can take the derivative of any polynomial, even if it has infinitely many terms, using these rules that we've talked about.